Hey everyone, so for my first video lecture I'm going to go back over the concept I last talked about in class. So I'm going to redo one of the practice problems for balancing redox reactions in acidic conditions. So first I want to write out step by step what we need to do for these types of problems. So the very first step, you need to figure out what will be oxidizing and what will be reducing. So identify species that are oxidizing and reducing. Then, once you've got that, you need to write out the half reactions. So that again is when you just take the molecules that have the species that are reducing into one reaction, and then take the molecules that have the species that is oxidizing into another reaction. Then once you get those half reactions written out, you need to balance any elements other than hydrogen and oxygen. And again, you'll be doing that with only coefficients, as if we were balancing a normal reaction. Once you've completed that, you need to balance oxygen atoms using water. Then balance your hydrogens using H+ ions. Then you need to include the electrons. And lastly, balance electrons and combine the half reactions. Alright, so these are the steps you always need to follow whenever you're balancing a redox reaction. So, for the first step, in order to identify what is oxidizing and what's reducing, you need to know the oxidation numbers for every element. So let's go through. Here, this is not one of our exceptions for oxygen. So the oxidation number for oxygen is just going to be -2. There are 3 oxygen atoms, each with a -2 oxidation number. So that's -6 total. When you add in the nitrogen, it has to add up to a -1 charge. So nitrogen has to be +5. Hydrogen here is bonded to a non-metal, so that means that you're going to have a +1 oxidation number. There's 2 of them, so it's +2 total, which means that sulfur has to have an oxidation number of -2. S8 is pure elemental sulfur, all by itself, and it's not charged, so it has to have an oxidation number of 0. And lastly, this is also not one of our exceptions for oxygen, so it's going to have an oxidation number of -2, which means the nitrogen has to be +2. So now nitrogen is going from +5 to +2. That means the nitrogen is reducing. It has to gain electrons, so its oxidation number goes down. So that is reduction. So I'm just going to put an R for reduction. And sulfur goes from -2 to 0. That means its charge had to go up, which it did by losing electrons. So I'm just going to put an O here, indicating that, well, here I'll put an OX just to differentiate from the 0 here, that sulfur is oxidizing. Okay, so now that we know that, we can write out our half reactions. So for the reduction half reaction, let me just slide this up a little bit. So I'm going to put reduction, and remember, it has to have all of the molecules that contain the species being reduced, which is nitrogen in this case. So we would write out NO3- yields NO. And then for the oxidation half reaction, we have to include the molecules that have the species that's oxidizing. So it's going to be H2S yields S8. Okay, so now step 2 is complete. Let's move on to step 3. balance any elements other than hydrogen and oxygen. For the reduction half reaction, the nitrogens are equivalent. There's only one on each side, so we don't have to worry about that. But for the oxidation half reaction, we have 1 sulfur on the reactant side and 8 on the product side. So it means we need to put an 8 here to balance the sulfurs. And now we're done with that step. Let's move on to step 4, balancing oxygen using the waters. So for the reduction half reaction, we have 3 oxygen atoms on the reactant side and only 1 on the product side, which means we need 2 more on the product side. So we're going to have to put 2 water molecules, since each molecule of water has 1 oxygen atom. Now oxygens are balanced. Down here, there actually are no oxygens to take into account, so we don't have to worry about this step. So step 5, balancing hydrogen using H+. We have 4 hydrogens here on the product side, and nothing here, so we have to put a 4 H+ here on the reactant side. In this oxidation reaction, we have 16 hydrogens, 8 times 2, so we have to put a 16 H+ here on the product side to cancel that out, or to balance it out. Alright? Now the electrons. So we have 1 element of nitrogen on both sides, and we set up here that nitrogen goes from +5 to +2, so if every element of nitrogen has to gain 3 electrons, and there's only 1 element involved, then that means that the total for this reduction half reaction would be 3 electrons. And since it's reduction, they have to go on the reactant side. Because remember, we're saying we're gaining them, so it's like they're a reactant and combining with these species to form your products. For sulfur, we said that each individual element of, or atom of sulfur goes from -2 to 0, so each sulfur is going to be losing 2 electrons. Down here we see that on each side of the reaction we have 8 sulfur atoms. So if 8 sulfur atoms are involved, and they're each going to be losing 2 electrons, we're going to be losing a total of 16 electrons. And since it's oxidation, we need to put those on the product side. Okay, so we're done with step 6. Lastly, we need to balance the electrons and then combine the reactions. So balancing the electrons. Remember, we've got 3 electrons here and 16 here. But when you're combining these half reactions into your final overall reaction, you need the electrons to be equal between the two so that they completely cancel out. Because remember, you should not end up with any electrons in your final reaction. So the way we can balance these is basically just by multiplying each reaction by the opposite number of electrons. So multiply this reaction by 16, multiplying this reaction by 3. Sometimes you can do it with smaller numbers. In this case, we can't, though. So I'm going to rewrite these half reactions with these numbers distributed across. So we have 16 times 3, 48 electrons, plus 64 H+, plus 16 NO3 minus, yields 16 NO plus 32 H2O. So this is our reduction half reaction rewritten with the 16 distributed. Now I'm going to do the same for the oxidation half reaction with 3 distributed. So we're going to have 24 H2S. Oh, I apologize. Yields 3 S8 plus 48 H plus 48 electrons. We have the same number of electrons on both of them, so we know that we did that properly. So now we just basically have to combine the two. So when we do that, anything that is on opposite sides of the reaction between the two, you can cancel out. So again, the electrons should always cancel out. Here we have 64 H plus ions on the reactant side, and here we have 48. So that means that each side of the reaction, the reactants and the products, both have at least 48 H plus ions. So we can cancel out 48 H plus ions from each side, leaving us with 16 left over here. Often you'll be able to cancel out the waters, but since the oxidation half reaction did not use any water, we actually can't do that in this case. So that's all we can cancel out. So now let's just rewrite what we have. So we have here 16 H plus 16 NO3 minus, keep going down to here, plus 24 H2S yields 16 NO plus 32 H2O plus 3 S8. Alright, and basically at the end here, now you just want to double check, as you would with all balancing reactions. You just want to look at the coefficients and make sure that you can't reduce them. 16, 16, 24, 16, 32. Up to that point it looks like you could, but then you have the 3. So there is no, so that is actually the smallest ratio, and that is your final answer.